The sun, our life-giving star. It burns at over 5,500 degrees Celsius, drives weather and lights our world. But it's also capable of violent, unpredictable outbursts that have stunned even the brightest minds in science. Imagine a star, a churning inferno of nuclear fusion, capable of unleashing more energy in a single moment than all the bombs ever detonated on Earth. That, my friends, is our sun on a bad day. Today, we're diving into the most shocking solar events ever recorded. Mysterious, powerful, and at times terrifying. Get ready to be amazed by the wild side of our sun. Let's journey back to 1859, a time when our understanding of the sun was as dim as a candle compared to the electric lights just beginning to illuminate our cities. On September 1st of that year, the sun unleashed a fury unlike anything humankind had ever witnessed. Richard Carrington, a dedicated skywatcher, was observing sunspots, those dark, cooler patches on the sun's surface. Suddenly, he witnessed an unimaginable spectacle. Two blinding white lights erupting from the sunspots, brighter than anything he'd ever seen. What Carrington observed was a massive solar flare, an eruption of energy so intense it made the sunspots themselves seem insignificant. But the real drama was just beginning. This flare was accompanied by a coronal mass ejection, or CME, a colossal wave of charged particles hurled towards Earth at millions of miles per hour. When this CME slammed into our planet's magnetic field just 17 hours later, it triggered a geomagnetic storm of unprecedented scale. Imagine a world where the skies ignite with auroras, not just at the poles, but as far south as Cuba and Hawaii. Telegraph systems, the cutting edge of communication at the time, went haywire, spitting sparks, setting papers ablaze, and even delivering electric shocks to operators. The Carrington event was a wake-up call, a stark demonstration of the sun's raw power and our own technological vulnerability. If such an event were to occur today, in our world tethered by invisible lines of electricity and radio waves, the consequences would be far more disruptive. Satellites could be fried, power grids knocked offline, and the internet, our lifeline to information and communication, could be plunged into darkness. Fast forward from 1859 to October 2003, a time when our technological dependence had grown exponentially. As Halloween approached, the sun decided to deliver a series of tricks and treats we wouldn't soon forget. It began with a series of powerful solar flares, eruptions so intense they overloaded sensors on solar observation satellites, temporarily blinding our eyes in space. Imagine the surprise of scientists staring at blank screens where once vibrant images of the sun had danced. It was like the sun itself had decided to play a cosmic prank, reminding us that even with our advanced technology, we were still at the mercy of its whims. These flares, now known as the Halloween storms, unleashed a barrage of X-rays and charged particles that bombarded Earth's atmosphere. The effects were immediate and widespread. Satellites, crucial for communication, navigation, and imaging, experienced glitches and outages. Airlines were forced to reroute flights away from polar regions where radiation levels spiked. In Sweden, a power grid overloaded, plunging tens of thousands of homes into darkness. It was a stark reminder that even in the 21st century, even in developed nations, we were not immune to the sun's fury. The Halloween storms were a taste of what a powerful solar storm could do, a preview of the potential chaos that lurked just a coronal mass ejection away. In July 2012, the world narrowly avoided a solar catastrophe. A massive coronal mass ejection, potentially as powerful as the Carrington event, erupted from the sun, aimed directly at Earth's orbital path. It was a cosmic bullet, a silent and invisible threat hurtling towards us at millions of miles per hour. Had this CME hit Earth, the consequences would have been devastating. Scientists analyzing the data after the fact were stunned by the sheer power of the event. They called it a solar superstorm, a force capable of causing widespread technological chaos. Power grids could have collapsed, plunging entire continents into darkness. Satellites, our eyes and ears in space, could have been fried, disrupting communication, navigation, and weather forecasting. The internet, the backbone of our modern world, could have been severely disrupted or even knocked offline entirely. Imagine a world without GPS, without cell phones, without the constant flow of information we take for granted. It's a chilling thought, a glimpse into a future that thankfully did not come to pass. But the 2012 near miss served as a stark reminder of our vulnerability. It was a cosmic wake-up call, urging us to prepare for the inevitable day when the sun once again sets its sights on Earth. Chapter 4: Mysterious Solar Radio Bursts, the Sun's Enigmatic Messages. Imagine listening to the radio, only to hear a burst of static, a brief but powerful signal interrupting the music or news. Now imagine that this static is coming from the sun, a star 93 million miles away. That's the mystery of solar radio bursts, strange and unpredictable signals that have puzzled scientists for decades. These bursts, often lasting only milliseconds, are powerful enough to interfere with radio communications, radar systems, and even military operations. They are the sun's whispers, brief but potent messages carried on waves of radio energy. But what are they saying? What secrets do they hold? Scientists believe that solar radio bursts are linked to the intense magnetic activity within the sun. One theory suggests they are caused by solar flares, those sudden bursts of energy that erupt from the sun's surface. Another theory points to magnetic reconnection, a process where magnetic field lines snap and reconnect, releasing vast amounts of energy. But the truth is, we still don't fully understand what causes these enigmatic bursts. They remain one of the many mysteries the sun holds close, a reminder that for all our scientific advancements, we still have much to learn about our nearest star. Chapter 5: The Unusual Sunspot Cycle. 24. The Sun's Unpredictable Mood Swings. The sun, like any dynamic system, goes through cycles. One of the most well-known is the sunspot cycle, an approximately 11-year period characterized by the waxing and waning of sunspots on the sun's surface. These sunspots, cooler and darker than the surrounding areas, are regions of intense magnetic activity, often associated with solar flares and CMEs. Scientists had come to expect a certain level of activity during each cycle, a predictable rhythm of solar storms and quiet periods. But then came cycle 24, which began in 2008 and ended in 2019, and it threw everyone for a loop. Instead of the expected surge in sunspot activity, cycle 24 was unusually quiet, the weakest cycle in over a century. There were fewer sunspots, fewer solar flares, and weaker solar winds. It was as if the sun had decided to take a nap, a cosmic siesta that left scientists scratching their heads. Some speculated that the sun was entering an extended period of low activity, perhaps even a mini ice age that could cool the planet. Others argued that this was just a temporary lull, a brief respite before the sun roared back to life with renewed fury. The truth is, we still don't fully understand why cycle 24 was so weak. It was a reminder that the sun, for all its regularity, is still capable of throwing us curveballs, defying our expectations and keeping us on our toes. Chapter 6: The 2023 Surprise Flare, a Cosmic Sucker Punch. In 2023, the sun proved once again that it doesn't play by our rules. A powerful X-class solar flare, the most intense category of flares, erupted from a sunspot that was facing away from Earth. It was a cosmic sucker punch, a reminder that even when we think we're out of the line of fire, the sun can still surprise us. Scientists, monitoring the sun's activity, were initially unconcerned about this particular flare. After all, it was on the far side of the sun, facing away from our planet. But they had underestimated the sheer power of this eruption. The flare's shockwave, a ripple of energy traveling at millions of miles per hour, was so intense that it warped our planet's magnetic field, even though it wasn't directly facing us. The effects were felt around the world. Satellites experienced glitches and outages. GPS systems, reliant on precise timing signals, were disrupted. It was a stark reminder that even indirect hits from the sun can have real-world consequences. The 2023 surprise flare was a wake-up call, a reminder that we are constantly bathed in the sun's energy, and even seemingly insignificant events can have far-reaching impacts. It underscored the need for constant vigilance, for better understanding and predicting the sun's behavior, and for developing technologies that can withstand its occasional tantrums. Chapter 7: Why Solar Weather Matters and Should Scare You a Bit. We've journeyed through time and space exploring some of the most shocking solar events ever recorded. But why should we care? Why should we worry about what happens on a star millions of miles away? The answer is simple. Our modern world is incredibly vulnerable to the sun's whims. Our entire technological civilization, from the power grids that light our homes to the satellites that beam information across the globe, is built upon a delicate foundation susceptible to solar storms. A single powerful CME, like the one that narrowly missed us in 2012, could cripple our communication networks, disrupt our financial systems, and plunge us into a technological dark age. Imagine a world without GPS, without cell phones, without the internet. Imagine hospitals unable to function, airplanes grounded, and cities plunged into darkness. It's not a pretty picture, but it's a possible future if we fail to prepare for the inevitable day when the sun unleashes its fury. The good news is that scientists are working tirelessly to understand and predict solar weather. We have spacecraft constantly monitoring the sun, sophisticated models that can forecast solar storms, and engineers developing technologies to protect our critical infrastructure. But there's still much we don't know. The sun remains a mysterious and powerful force, capable of both sustaining life and threatening our technological existence. It's a reminder that we are but a small part of a vast and awe-inspiring cosmos, and that our future depends on our ability to live in harmony with the forces that shape our universe. The sun is a source of life, warmth, and energy. It's the reason we're here, the engine driving our planet's ecosystems. But as we've seen, it's also a source of incredible power that can disrupt our lives in an instant. Which solar event shocked you the most? Let us know in the comments. And if you enjoyed this dive into solar science, hit that like button, subscribe, and fuel your mind with more cosmic facts. Only here, on iStoke.